Hello everyone, and welcome back to Technically Unsure, where I'm not really sure what I'm doing technically.
Well, I don't rightly know, to be honest.
So today I have some very interesting boards to share with you, and it is mainly topic of today's video because this is a board that's been built by OrangePi, but the SoC is from Huawei. And they are trying their best to keep it out of a US and basically out of China. So the only way for you to buy this for now at least, and it's been like that for a while, that is only from China, and you need to be in China to buy it. And even downloading the firmware and the manual and the OS image, they are all behind the Baidu cloud wall. I know you can technically download it even if you're not in China, but the trouble you have to go through it makes it, a lot of people just skip and you're not gonna be able to do it easily. It's a long process just to download the image and the manual and stuff for this board. Let me share how I got into this. So this is the article that got everything started. Huawei and OrangePi launched new board, mystery CPU and AI processor. Huawei hides the chip specs from the prying eyes. Literally, it says the quad-core mystery chip with a built-in AI accelerator, right? And this is the image of the board with the explanation of what is what. The Huawei and China is under some sanctions related to the chip and CPU, and basically their access to many things is limited in terms of chip production. So they are hiding it. Like, I don't know the nanometer of the CPU, and there is not much also explained in this article as well. And it is just said that this is based on custom Huawei Kunpeng CPU design. What else? Like Kunpeng processor, okay. Any specs there? How many, gigahertz, megahertz? There is not much going on in here. It explains that it is 4-core 64-bit Kunpeng processor, Pro processor, plus AI processor, and GPU is just integrated graphics processor. There's nothing going on in here, and that this one AI processor provides 8 TOPS. So for the sake of comparison, they're comparing it to Snapdragon Elite or Apple M4, which is unfair. I think they should compare this. It's a tiny SoC with a tiny development board. Closest to that would be ROG 5A-B from Raxa. So I would say Raxa ROG 5B, the more expensive, the bigger one, does have a 6 TOPS NPU. This one has 8 TOPS. So I wouldn't compare this to Apple M4. Anyway, there is this 8 gig and 16 gigabyte version, and then there is the NVMe SSD interface in there, eMMC slot is in there, TF, this SD card is in there, Wi-Fi is dual band 5 and 2.4, Bluetooth is 4.2, that's let down. Like every single new board that's coming out is at least Bluetooth 5, Bluetooth 4.2 anyway. And the Ethernet is also let down. All the new boards that coming out is usually 2.5 gigabit now. It's coming pretty standard. Now it's again a gigabit Ethernet. And there are 2 HDMI 2.0s, can do 4K at 60 FPS. I guess kind of like Raspberry Pi 5. And there's like MIPI and CSI and 2 camera interfaces, USB 3, 2 USB 3 ports, and fan and so on, and 40-pin GPIO. But from the image I saw, I don't think they are just like the Raspberry Pi. The size is smaller, but I might be wrong. And then this is it. Kunpeng 8 gigabit motherboard, cooling fan, 64 gigabit eMMC, that's 1,076 yuan, which is $150. This is 16 gigabit version is $183. 8 gigabyte with a case is $166, and 16 gigabyte, 64 eMMC, and a metal case and a power supply, that's $200. I got this one. Even though it's near impossible to buy it. You let me know if you can buy it, but I don't think so. So, they are trying to keep it out of sight, especially the specs, and you can't really easily buy it or download its image. So let me show you what I got. This is literally the box. I did not open. I just opened this box and removed the labels. So this is what you get for 200 bucks, okay? Keep that in mind. You get one USB-C cable. You get OrangePi Kunpeng Pro, okay? This is literally it. And this is the board. We're gonna open this up. Let's see what else is in there. And obviously there's going to be not US. Oh, it is US. Okay, that's interesting because they don't sell it to US. Why it comes with a US plug? I'm seeing it with you. I didn't open it before. I'm serious. That's a mystery to me. I don't think Chinese. No, China, I think they are using like the European style connector. And in terms of specs, it says right here that it is 110 to 240 volts is accepted. And the output is 5 volt 3 amp, 9 volt 3 amp, 12 volt 3 amp, 15 volt 3 amp. Yeah, so it supports all sorts of voltages, all 3 amps. Okay, keep that in mind. Yeah, there's nothing else in the box. Let's unbox. There is nothing on this. Let's see, how does it look? All right, so this is the metal case, okay? And it does have labels. So DC, basically meaning power supply, which is USB-C, HDMI 1, HDMI 2, audio jack, Type-C, another USB Type-C, USB 3, USB 3.2, and the LAN Ethernet, 1 gigabit Ethernet here. There is a micro USB port over here. There is a power button, reset button, and a flash. What is going on here? I don't know yet, so we'll figure it out. Yeah, so this case looks fancy, but okay, so that's magnetic and you can open it up easily. And that's the board. It's beautiful. So this is the antenna, the Wi-Fi and 2.4, 2.5 gigabit antenna is behind and connected to this. We have the GPIO, as I said, this is not the same size as Raspberry Pi, it's a different size. So yeah, this is a little bit different. The CPU is underneath this. Before I remove this and take the cooler off and everything, I just want to first see if it is going to work. I just want to see if it works. I see this is here, this is the Wi-Fi module. This is Wi-Fi 5 and Bluetooth 4.2 module. These two are the RAM chips. Okay, 16 gigabyte. The Ethernet, and we talked about that. This is MIPI-DSI. This one is MIPI-DSI, and these two are CSI. Yeah, camera 1 and camera 0. So this is camera 0, this one, and this is camera 1, and the last one in here is DSI. So this is display, camera. That's kind of pretty much it, okay? The case looks very fancy. It's very well built. It's metal, okay? And the operating system for this bad boy is OpenOiler. It's basically Huawei's operating system that's based on Red Hat, okay? So I already downloaded the image from the cloud, Baidu cloud. So let me put this back on. I guess this goes this way because of the fan, okay? Easy. Yeah, so let me power this on, connect the HDMI and everything, and let's take a look at it. There is actually an NVMe SSD behind this, so I don't want to take it out right now. It's all ready to go. I just want to test it with their own cooling and everything. So when I'm doing benchmarks, I want to keep it with the case and cooling and fan and everything. Let's do the software tests and benchmarks and try the operating system, and then we're gonna take one final look once I take it out to the board itself and the CPU, SoC, and the NVMe SSD. We're gonna install something on it. Give me a couple of minutes, let me put everything together and connect the cables, and we'll take it from there. Okay, so we are back, and I have connected all the wires and the power. You will see this on the other camera, the power consumption. And I have the multimeter and also this oscilloscope in here. I'm gonna talk about it why I brought everything out. So let me turn it on with the power button, which doesn't do anything. I'm gonna move and plug that back in. So let me see if you can hear it. You hear that? And now you see something on the screen soon. So yeah, just keep in mind that happens every time you reboot, and you see the power consumption is around 2 amps. Yep, and it boots fast. So we are booted, and as you can see, the username OpenOiler. So the same spelling and the same password is same. So basically, what I mean is E is capital. Okay, so and everything is Chinese. But I gotta give it to them. Honestly, I was able to burn the SD card and log into it and connect to Ethernet, and everything was working fine. So let me open up the terminal, and I just want to show you a couple of things very quickly. Okay, so when you open it up, this is how they have their terminal. So it already shows a lot of stats and information over there. And it's all Chinese, as I said, even like, you know, let's do LS, you see? So what I did was I just memorized. I can't read Mandarin. So basically this is downloads folder. I just said like, this looks like an TNF combined. So I say that's the download folder. That's all I figured out. So anyway, let me maximize this and do a fast fetch. Okay. So there are some information over here. As you can see, we are at the 1080p for now, and this is Linux 5.10. Very common kernel in SBCs of this size. So you have seen it. OpenOiler 22, GNOME 3.38, and so on. There's GPU is LLVM pipe. So here's the deal. This is their own provided Chinese operating system, Ubuntu. I mean, OpenOiler image, not Ubuntu. It's RPM based. It's CentOS RPM Red Hat based. Okay, and yeah, it's on their own image, and I cannot get anything to work in terms of GPU or TensorFlow or other stuff. So I will show you. So as you can see, this is a CPU, and the RAM is 16 gigabyte, right? Okay, let me do a very quick sysbench, right? Watch this. So let's do a sysbench for CPU run. As you can see, we are getting 8,000, right? So just for reference, 10,000 is the RPi, Raspberry Pi 5, okay? Also ROG 5A, ROG 5B, which is using RK3588. What I mean is it's a little bit low, okay? Just keep that in mind. $200 SBC, that's a little bit low. But the important thing is they're saying there is a lot of AI acceleration and other things, but the problem is I can't get it to work. Let me show you a couple more things. So for instance, let's try the PWM example, right? That's the purpose of the oscilloscope right here, right? So I connected that to, by the way, they have a very good documentation on the pinouts, okay? So as you can see, here is the PWM3, okay? And the PWM3, if you hold the board like this, as you can see, the Ethernet and the Ethernet, right? So this way. So the first one over here should be 3.3 volt, and the next to it should be 5 volts. And I wanted to double confirm that. So let's actually do that. As you can see, the first pin over here, that is 3.3, as you can see. Okay, can you see? Okay, 3.3. And if I go to the pin next to it, that one is 5. Okay, so we got this side, and now from this side, 1, 2, 3, 4, 5, fifth pin from this side, I inserted this. And as you can see right now, there is nothing on the oscilloscope. It's flat lined. Okay, there is nothing going on. But they have an example. So you have to go to CD OPT, and then we have to go to OPI test. And there are a bunch of examples, bunch of tests that you can run that does stuff. Okay, so let me see actually. So hello world, audio, camera, memory, fan, firmware, HDMI, LCD, NVMe. Yeah, these are the stuff, right? SATA and all that. So what we are going to do is we're going to try the PWM. So in the PWM, they have the test script. Now look at this. Okay, so now it's going to generate a PWM signal, and you have to run that with sudo, so it doesn't work without sudo. Test and open Euler. There you go. As you can see, hopefully you can see. Yeah, you can see. So that's what you are going to see when you generate the PWM signal. So for reference, okay, as you can see, we are generating this signal, right? And if I go to a regular 5 volt or 3.3 volt, so we get the flat 3.3 volt in the middle, right? But if I go back to the 3.3, sorry, to PWM pin, this is what I'm getting, okay? So PWM signal generation on this board, sorry, works properly. Another thing I want to show you is actually GPIO test. So they also did a great job on that. I have to give it to them. So I saw enough share of SBCs with no documentation and non-working GPIOs that now somehow it's a praise point. Now I have to say, oh, they did a great job. I think GPIO works, for God's sake. Yeah. Anyway, so let's do that. So I'm gonna choose, let's say with this one, okay? As you can see, it says, I chose that because I'm lazy, so I'm choosing the one opposite of the PWM signal. So wherever I put the PWM, on the other side, that's going to be GPIO number is 84, and that is GPIO 20 pin, okay? Let's do that. I switched to that, okay? To the pin next to it, and as you can see right now, it is 0. Now, if we do echo 84 to sys class GPIO export. Okay, we exported it. Now the out to the sys class GPIO, what was it? 80 GPIO 84 direction. So that's going to be an out pin. And now I am going to echo 1 to make value. Oh, that is still connected to that. Sorry, my bad. It's connected to the oscilloscope. I have to switch. So yeah, this one. I have to remove it from the oscilloscope and put this one in. Okay, so now as you can see, it is on the 3.3 volt, and you already saw that in the oscilloscope as well. So now if I put the value to 0, if I go back, make the value 0, that drops to 1.5. All right, I guess, all right, maybe there's other functionality on that pin. Anyway, it dropped to 1.5, why? Hold on, is it because of this? Okay, yeah, sorry, my bad. That was the oscilloscope, okay? That was interfering. Let's do the test again. I am going to echo 1, 3.3, as you can see on the on the multimeter. And if I do 0, it drops to 0, okay? Yeah, so it works, and GPIO works, PWM signal works. Sysbench we did already. You saw the results. So let me remove these stuff. It's a mess over here. Let me turn it off. Turn this off. Okay. So we did those things work, but here's the deal. I told you about that. Let me go to the download folder, which is this thingy, whatever that is. Okay. I downloaded a bunch, right? So if I do ffplay, obviously it's not going to use the GPU because the driver is not there. Nothing is properly done on this operating system. So if I do ffplay, let's go with the MP4 file, LGUHD Greece, right? Look at that. So this is a 4K video. Okay. So you already see the stutter. I don't even need to show you the frames. Oh, look at that. You already know, what's happening, okay? If I go back, you will see frames drop is going crazy, okay? So FFY obviously doesn't work. Another thing you might say, okay, how about the Chrome or Firefox, whatever they are shipping it with, right? So same story. If I go to youtube.com, right, and search for the 4K demo video, so the video is loaded. I guess this is stat for nerds. Yeah. So yeah, even what is this, 480? Yeah, 720. So 720, it is dropping frames. Forget about 4K, 480. So if I go 1080, look what happens. Frames dropped, frames dropped, frames dropped. Yeah. So there is definitely driver issue. This is the official image for this board. Somebody might say you have to install this, you have to install that. I couldn't, first of all, but that is something that the seller should provide. That whoever made this board, they provided an OS image, nothing is working. So if that's, what is the purpose of image then? And I can just get something my own and install it. So when you provide the image as vendor, your image should have every driver and everything working on it, or at least the instruction. There is none of that, okay? So that is also not working. And let's see, so if we go back to the sudo root shell, stress ng test also, let's do that, CPU 4. As you can see, when the benchmarks are running, it goes a little bit above 2 amps, so it goes to 2.5-ish. I gotta say, it's kind of efficient though, so anyway. But it is, yeah, 5 volt and 2.5 amps, and it is doing this. So as you can see, it's 661, right? So yeah, it's below Raspberry Pi 5 or RK3588 and chips like even RK3588S. It's way slower than those. And if it is some sort of CPU, I don't think it's a driver issue. It just, it is what it is. The GPU and NPU stuff is not there. As you can see here as well, it's even the CPU doesn't have much information here, nothing on the GPU, and TPU is also NPU, TPU, AI chip, whatever, is not working. So yeah, this is the situation, and it is not really doing great. The only other thing is, let me just try the Ethernet. Okay, let's try the iPerf3 and P50 bidirectional, and okay, yep, and that's the gigabit Ethernet. So yeah, it's nothing groundbreaking. It just deliver what it promised, and it is it's working. Another fun thing is, this is HDMI 1, this is HDMI 0. Just don't get confused. I was plugged in this HDMI into HDMI 0, and it did not show anything on the screen, so you have to use this one in order to see something on the screen. So keep that in mind. But yeah, this is there is nothing really much in here. So they provided some good examples. I have to give it to them. There is a dev kit also. There is also another cross-compile tool chain they provided. You can use that as well. There is a compiler and everything here. So yeah, they have the Bshank compiler. So they provided the tools. They provided some testing, like for instance the one we tested, right? The PWM, right? That was right here. But I don't see much more here that we can do. Actually, let's check the ResNet picture thing. Let's see what's going on in there. There are built, and see the build. Let's see if it is built already. What? No, it's not built. And there's a makefile. Yeah. So it errors out, and the example they have provided does not compile, and it is looking for image active light DVPP little image. So whatever library this is, I'm not familiar with it honestly. ACL Lite, I don't think I know about that library. But yeah, the sample they provided for the ResNet, that's not even compiling. So if we search for this, yeah, it comes back to something that they have. It's not coming up here. AC. Yeah, I'm not familiar with this, and this is some header missing somewhere, and obviously this is again their board, so it should have been working all out of box. So, and let's go here. Okay, so that's exactly what they're saying, right? Let's do. Let's follow, see the model. Okay, we can get the models, that's not a problem, but we have bigger problem. The problem is not the data as well. The problem is here, running and building it, right? Doesn't work. So if we go to the cd scripts and bash sample build, doesn't work. That's the problem. So the example they have provided for the ResNet, that's just not working. And because of that, I can't really get this to work. Yeah, so their own example doesn't work. And other examples, the only one I got to work without issue was that PWM. And NVMe I haven't tried yet. We are gonna try that. Okay, I see an ACL light here. I'm assuming this is related to that. Nah, it's erroring out. It's erroring out. It's not going to work. ACL is missing whatever that is. So installation, nothing. Instruction, nothing. Yep. That's what it is. That's what I'm telling you. This is ACL light. It's probably related to that other ACL error, but it just doesn't work. It's not getting compiled. There's no documentation, and their own script is not working. So yeah. Let's see what else is there. And yeah, I don't think this ACL is related to file system ACL or anything like that. This is some other some library they are talking about. Yeah, I can't even find it on Google. As you can see, this is sys ACL. This is access control list for Postgre. It's not. So yeah, I don't have anything for that library, and I can't get any of these examples to work, not RasNet, the other ones. But yeah, the driver doesn't work on this. I couldn't get the GPU or NPU to work. But the rest, I mean, Ethernet is fine, HDMI is fine. These are basic. Probably those are provided by the OrangePi as well. They already have so many other SBCs. But with the SoC, which is all about this buzz over here, Huawei and the chip and the, what was the name? Kunpeng, whatever, Kunpeng Pro. Yeah, so that Kunpeng Pro, I don't see that in here. Even on the fast fetch or any other sysinfo, it does not show up. And yeah, so what I'm gonna do is I'm gonna take this out and try to see what is in the other side and maybe try the NVMe slot. Otherwise, yeah, there's not much else to do here. I will be right back.
A few moments later.
Okay, I am going to remove the heatsink. There you go. Oh wow, that's a tight. Okay, look at the chip. Look at the chip. Can you see it? Oh yeah, there you go. So HI1910 RFI V110, and then there is JTQQ1Q8UO 6337CN. So that's the CPU SoC. And by the way, it doesn't get toasty, so honestly this is very efficient. So I'm trying to figure out how I can get this out. There is no screws on the other side. I removed the leg, the pad in here. I didn't see anything underneath. Yeah, there's no screw under here. So I'm assuming, okay, I'm going to just try to remove these standoffs. Maybe that is what is holding the board in there. Oh boy, that's a real challenge. If that's the way I should be doing it. Let me see. Yeah, looks like it. Looks like it. Yep. If I remove this, this will be able to come off. Okay, finally, I took all 4 out. There you go. And board fell right off. Okay, so we are going to put this for now back. And but no, actually, let's look at it. So underneath there is let me actually remove this. Okay, so let's put this away. All right, so this is the board, and there's not much going on. This is UART. Okay, so that's the micro USB port. There is also UART on GPIO, just so you know. Camera stuff we talked about, the RAM, the Kunpeng Pro CPU over here, and if we flip it over, there is the 64GB eMMC, and there is the PCIe slot right here. So they have, yeah, Kunpeng Pro 16G, and we can install an NVMe SSD over here. Oh, there's a switch, boot 1 and boot 2. I assume this is to switch between eMMC and the SD card or the SSD. I guess that's related to that. So let me install an NVMe SSD 2280 and let's see if it actually identifies and detects it. I will be right back. Okay, so I installed the NVMe SSD. There is not much else to really cover over here. Oh yeah, there's some explanation. Yep. There's explanation. Okay. All right. So here's the explanation. So right and left, I think. Right, left is SSD. Oh yeah. So right. Which one is right though? This is boot 2 is left. I assume they are saying this is right, this is left, something like that. But which orientation? Anyway. So let's go with that. It says right left is SSD, left right is eMMC, right is SD. Okay, so we put this on the, so right now it's on the SD card because it is booting from the SD card. Okay, so it's saying right. So yeah, it is on the right. This one is on the left. This is right. So right SD card. And if we do left right, this one be left. Oh yeah, there's left is this side. So left and this one right will be eMMC, and putting this one on the right and this one on the left, that's going to be SSD, which is this. Okay, so for now let's put back to right, which is SD card. Let's leave it at that. And let me put back this heatsink and the fan, and I am just going to leave it like that. It is strong enough to cool it, and I don't need to screw it down. Okay, now let's get ready. Power consumption jumps up to 2.7 when it is running the fan test. Well, obviously those switches are incorrect as it didn't boot. So I'm going to put it on the incorrect situation. Left to boot from eMMC, right, but yeah, right doesn't work. I'm gonna put this on the left. That's what it was on, and let's see if it boots now. Okay, so this one worked and it booted. I just want to make sure that the SSD, NVMe SSD is detected, and I want to see the speeds on that. The PCIe 3 Gen. Right, so let's go to terminal. Yeah, Gported installed. Oh my god, I keep forgetting the sudo. That's why I always go just sudo-i drop to the shell, because I will keep forgetting it. Well, let's go with fdisk. Okay, so what we have over here, that's going to be so this is my SD card. This is the internal that I know. Oh yeah, it detected. Yeah, that's the Windows. Yeah, it detected it all. Okay, so it detected it. Okay, so yeah, it seems like working. Okay, let's do LSPCI. And let me see. I want to find that device. Yeah, there you go. This is it. Okay, so speeds are, looks like, yeah, it's just like similar to X4, just like Raspberry Pi 5. Okay, so looks like NVMe SSD is also working, and yeah, looks like everything that is okay. One more thing. Is there a P sensor in OpenEuler? No. That sucks. LM sensors is there, so why it didn't install? Okay, the sensors are there. Well, when I run it though, well, that's I2C. No, it is not detecting. No, this is I2C device. I'm not sensors. Yeah, it is not detecting. And again, a very important reminder. This is the vendor provided image and it's not working. Yeah, so long story short, what I'm gonna say is this just sucks. Okay, obviously you're not gonna buy it, but I also don't get the hype and this. I get it. They try to hide the specs, but I mean, I am not seeing anything special on this. I can't even get it to work. I get it. They developed some CPU, but the dev board that someone can develop with it, I could barely get anything to work on this. These things do not work on this. So it's either the OrangePi or it's the Kunpeng CPU or whoever provided the image. SDK wise is bad, but I have to give them the signals and PWM and the GPIO, they are working. They have no problem. The problem is the CPU and drivers and support in the Linux. The GPU doesn't work, the NPU doesn't work. Barely their CPU can get close to Raspberry Pi 5, but it's nowhere near it. 2,000 points are missing on each test. So yeah, it is NVMe SSD is working. I have to give it to them. NVMe SSD works fine. But other than that, at least software-wise, they are way behind. They are very behind. They have a lot of work to do. Even the CPU temperatures are not getting reported in Linux. NPU and TPU and NPU, the natural processing or AI board, whatever they have, it's not working. And yeah, there is the examples they provided just simply sucks. They don't compile, they don't work, and I couldn't get anything else to work on this properly. Cool concept, cool idea, just doesn't work. Yeah, that's pretty much about it. I just wanted to show you. If you want me to, run something on this or have some ideas for me to run and try on this CPU, let me know. But yeah, no matter what I did, couldn't get it to actually do something useful with it. Temperature-wise, it's okay. If I remove it right now, yeah, no, it's not hot. It's not hot. So this is it, I guess. That's all for now. And please let me know what you think, if you want me to try anything in the comment section. Thanks for watching, and I will see you in the next video. Bye for now.